Mr. Sam's? There's lots of shapes in the world.
Yes, mine being the best.
Yours is the best shape, yeah.
Yes.
I'm in pretty good shape myself, yeah. I just got a 4-mile run today. And
Nice.
It's pretty fast.
I did not
actually.
run at all today.
Yeah.
I have not run since last Wednesday.
Uh-oh, that's
I
not
know.
good.
No.
Yeah, okay. I'm in shape, but that's not what we're talking about here. We're talking about the specific shapes of molecules. Now, when you see the word molecular, we're talking about
Molecules.
molecules. So let's talk about molecules. Before we can talk about the shapes, though, we need to sort of understand the overriding principle that helps us understand the shapes of molecules.
Vesper.
Vesiper. Or
Vesper. I know,
Vesper.
I've heard it called Vesper, but it shouldn't be Vesper.
I know, but they're trying to make it sound Englishy. Vesiper. So it's the valence.
Like those little scooters. Well, that's a Vespa.
There you go. This first one I think should make sense. Valence shell electron pair. Pairs
Pairs of
of
electrons.
outer electrons.
Yeah.
And then repulsion. What repulsion means they don't like each other.
Right.
If you're repelled, yeah, Mr. Sam's repelled by me. My breath must be repulsive, and so that's because electrons have the same charge.
Yeah.
And therefore
Negatives repel.
they repel each other. If you ever played with magnets, right? If you get the positive end and the negative end, and you take another one and you put the negative in with the positive end, they repel.
Yeah.
Electrons also repel because like charges repel, just like as we talked about previously. Opposite charges attract. Why, we don't know. Okay, so here's the general rule. Electrons want to be as far apart as is physically possible.
Okay.
That's the rule.
Okay.
So that's what determines the shape of a molecule. Now, when you're trying to determine the shape of a molecule, there's a couple of things we need to understand. There is something called an electron cloud.
Okay.
A cloud of electrons.
Yes. Now, if you talk to me, sometimes I refer to this as a thing.
A thing.
Because, yeah, we're going to talk about how many electron clouds are coming off of a central atom.
How many things.
Or how many things.
Yeah.
So in a thing or an electron cloud could be either
an unshared pair of electrons. So if I have, for example, SO2, that would be a good one.
Okay, we drew that in the last lesson.
Yeah, and if you don't know this, Mr. Bergman knows it. Here's SO2.
Okay.
So on the sulfur, we have an unshared pair. That's a thing.
A thing.
Okay. Or an electron cloud. We
Right.
have a
A
single, a double, or a triple bond. We've got a double. That's a thing. And we have a single bond, and that's a thing.
So that
how many things do I have?
Sulfur has three
things.
things coming off of it. It has the unshared pair, it has a double bond, and it has a single bond.
So it's
now,
three
the double bond does not count as two.
That's right. Double
It's
counts
still
as
just
one
a thing,
This
or
equals
an
one thing.
electron cloud is how we can also call
It's
this.
more appropriate. The
Right.
things make more sense.
Yes.
So, hey, here's the rules. You determine the number of clouds,
Or things.
right? You count the connections.
1, 2, 3. In this case.
This case would be 3. You count the number of unshared pairs.
Okay.
Well, actually, no. This is 2.
Oh, yes, sorry.
Number of unshared pairs, 1.
Yes.
They add up to 3 things.
Right.
And then you use the chart to determine shape.
And we'll talk about the chart in a minute.
Yeah.
Yep.
Now,
Okay.
to understand geometrically how this works, let's watch a little clip where I talk about
2 dimensions versus 3.
2 dimensions versus 3 dimensions. The goal in this thing called the Vesper theory is that you're trying to keep the electrons as far away from each other as possible because all electrons have the same charge. Remember, a bond, a line, is electrons, and electrons want to stay as far apart as possible. So if I were to have, say, an atom, or a molecule, pardon me, and I was trying to figure out what's the furthest apart, so let's say, if you have the central atom here, you would expect them all to be at about 90 degrees from each other here, right? 90 degrees, 90 degrees, 90 degrees.
I would expect that if it was a 2-dimensional object.
But you see, it's a 3-dimensional object, and voila, you can do better than that. You can actually get what's called the tetrahedral shape, where each of these angles is 109.5 degrees. 109.5. 109.5 is bigger than 90. So because a 3-dimensional object, we have to think in 3 dimensions. If you're doing it on a piece of paper, you want to make it this sort of cross type shape. It's even hard to do. But that's incorrect. When you have 4 substances, they want to be as far apart as is physically possible. Okay, so understand it. You've got to work in 3 dimensions when we're talking about this.
Mm-hmm.
So, hey, this is we're calling this
The shape sheet.
the shape sheet, or shape paper sheet. We'll call it the sheet. Okay, this is in your packet.
Yes.
If it isn't, then you could print it.
Yes.
Okay, so if you look at here, the number of clouds, or as Mr. Sams likes to call, these are the number of things. You have 3 choices: 2 things, 3 things, or 4 things. There's, by the way, 5 and 6 things, but in this course, we're not going to cover the 5
Right.
and the 6 things.
We'll save that for AP.
That's sort of an advanced topic.
Yeah.
And they're very rare anyways. Most commonly are 2, 3, or 4 things, or electron clouds. So here is our shape paper. You'll want to have a copy of this handy for you as we do some examples. So let's do some examples. So let's do several examples, Mr. Sams.
Alrighty, let's
so the
do it.
first one I want to do is CH4. Now, I'm going to just draw the Lewis structure because I know what they are. Okay, you guys would need to draw the Lewis structures based
on the rules that
on
we
the
did last
rules
time.
in a previous podcast. So here is CH4, also called methane.
Okay.
And we're gonna.
And if you want to see this built, it would look something like this. We have a
Yes.
central carbon with 4 hydrogens coming
So
out.
what shape would that be? We would refer to the shape paper and
Right.
we ask how many things. Now, Mr. Sams, how many electron pairs?
Let's
are on
look
here?
at carbon. I see 1, 2, 3, 4 single bonds coming off of that. So that's 4 things. Or
Yeah,
4
so the
clouds.
4 things. So if we look at the chart and we find 4 things down here,
Okay. Now all of those are a bond.
right?
So we're
Now,
looking at
a lot of
4
people,
things.
4 things, and they're all connected. In fact, CH4 it says here is one of the
our
examples. And so this would be something called
Tetrahedral.
tetrahedral.
Bond angles of 109 degrees.
So his shape is tetrahedral.
It's not a tetrahedron, by the way. It's tetrahedral.
Yes.
Tetrahedron actually looks like this. We're
Yeah.
talking about a 3-dimensional shape with sides. Okay, molecules don't have sides. So
Yeah.
we're talking tetrahedral shape like this dog toy here.
Okay. Our second example is going to be NF3. And again, I will draw the Lewis structure of NF3 and see if you can figure out. Again, when you do these, I'm going to make you draw the Lewis structures
Yep.
and then determine the shapes. But you can look at other podcasts
Yeah.
to determine what that one would
Now,
be.
while he's drawing that, this
Well, I
is what
think
it
we
would
should
look
go
like
to the
3-dimensionally.
shape paper first so they can see that.
Okay.
So if you go there, how many things or how many electron pairs, Mr.
We got
Sams?
4 things. We've got an unbonded pair, an
One
unshared
unshared,
pair,
okay.
and then we have 3 bonds.
3 bonds.
So that's a total of 4 things.
So that's a 4 things. So we're still down here at the 4 things.
Right.
And so 4 things, but there's one unshared pair right here.
Yep.
And then this shape is pyramidal. So Mr.
Right.
Sams, let's write that pyramidal and then you can talk about it.
Yeah, pyramidal. So it looks like this is derived from the tetrahedral shape. We've got the 3 atoms on the bottom, and then we have this unbonded pair of electrons here at the top.
So you can kind of see how it looks like a pyramid. The next example we're going to do is OF2. Now to draw OF2, again, Mr. Bergman is pretty good at drawing these. So again, I've done the math ahead of time, or I've seen these too many times that I know them by heart. Okay, how many electron pairs, Mr. Sams?
On the oxygen, I see 2 unshared pairs and 2 bonded pairs. So we're looking at 4 clouds or 4 things.
Yes, 4 clouds. So if we go to 4 clouds, but now we're down to this
Yep.
shape right here where we have 2 electrons that are unshared and 2 that are bonded.
Yep.
So that shape is the
Called
bent,
bent
104.5 degrees.
Now, again, to look at that, it's derived from the tetrahedral shape, the one I've been doing, but I just popped off the 2 atoms. So we have 2 bonded pairs here and 2 unbonded, unshared pairs here. Bent. Ooh, do I have that built? I don't. I can build one though.
This next one we're going to do is SO3. Now, again, I'll draw the structure SOOO. And actually, there's a double bond on one of the O's. And that would be 4 bonds. You're going to want to copy these down. So Mr. Bergman is doing this here. Now, on this one, if you were to count how many things there are, you've got 2 single bonds, I'll call them the SB, and 1 double bond. So that's a total of 3 things, 3 electron clouds. So I have 3 electron clouds, so I use my shape paper here. 3 electron clouds, and they're all connected by bonds, even though they're single or double. There's no double distinction here. So this is called the trigonal planar shape. Trigonal planar.
Okay, so if you want to see an example of that, here we have a trigonal planar molecule. This is the sulfur and the oxygens coming off it with the single bonds, and then the springs here represent the double bond. Trigonal planar.
All right. Hey, we just discovered something interesting about your shape paper.
Yeah, there's an error.
We'll fix it, by the way, for you to see this, but on the chart here, the SO3 is not SO3 negative 2, it's just SO3. It's an example of the trigonal planar substance. Okay. Let's do another one, SO2, sulfur dioxide. Sulfur dioxide is very similar to sulfur trioxide. That's what it's called. Its name is sulfur dioxide. So there's one sulfur and 3 oxygens. And on this one, it looks like this. Again, how many...
You're missing 2.
Oh, I am missing 2, thank you. How many clouds are on the central atom?
I see 3 clouds. We've got the 1 unshared pair.
1 unshared,
We have 1 single bond.
1 single bond,
And we have 1 double bond.
1 double bond.
And remember, don't count the double bond as 2. It's just 1 cloud, 1 thing.
That's still 3 things.
Right.
So we go to 3 things,
Uh-huh.
3 things right here, and then if you've got 1 extra pair of electrons, then this is this shape, which we call bent 120 degrees.
Okay, so to look at that, we've got bent 120. It looks real similar to the last one we saw, but instead of an atom being bonded here, we have an unshared pair at the top.
Good. All right, I think we've got a couple more examples, Mr. Sams. What is it? I2. The next one is I2, iodine. Now, iodine is actually super easy to draw. It's I, and then there's 6 electrons around each I. Actually 8 if you count the bonded pair. Now, this one's interesting, Mr. Sams. How many are there around? There's no central atom.
No.
Let's just take a look at the shape paper on this one. And so if you look at the shape paper, right here, what you have is when you just have 2 atoms, regardless of whether it's a single bond, double bond, or whatever, it's just called linear diatomic.
Diatomic meaning 2 atoms.
Yeah, diatomic. What does that look like, Mr. Sams?
Just like this. 2 atoms together, bonded, that's it.
Yeah, pretty simple. Okay, I think we're going to do one more. The last one we want to do is HCN. When you draw HCN,
And just as a note, H will never go in the middle, and if
Yeah.
you see carbon, it almost always goes in the middle.
yeah, so there it is. Now
Okay.
I count 2 clouds, or 2
Coming off the
clouds.
carbon, yeah.
You've
we-
got 1 single bond and you got 1 triple bond for a total of 2. So this is a 2 cloud system.
Okay.
So in a 2 cloud system, you have 2 clouds with 2 connections. It's this shape, and if you look right here, that's called linear triatomic. So this is linear triatomic.
Okay, so that looks a little something like this. I even put an unbonded pair that for the one that goes off of nitrogen. So we've got our triple bond here with the springs. We've got our hydrogen over here, and you can see it's in a straight line, linear.
So that's how you figure out the shapes. Use the shape paper, determine the number of things, electron clouds around the central atom, and you should be fine. Use that paper.
Yep, it's
Okay.
your friend.
Yep.